Hey, this is Michael with Access Woodworx, and today I'm going to be talking to you about 3D printing touch stylus for people with disabilities. Back in the fall of 2015, we bought our first 3D printer to help us make things for children and adults with disabilities. One of the most common requests we were getting were touch stylus that would work with capacitive touch screens. In the past, devices had physical buttons, and so we could easily make a touch stylus that someone could grip in their hand to hit the keys just out of wood, pencils, pieces of metal, whatever. And that would work just fine for them. But one of the issues we had found with touch screens is that the traditional stylus that we were using wouldn't work, or would be intermittent. Even if we used just a piece of metal, it didn't always move the screen around like we wanted it to. So, because they're designed to use with your finger. One of the things with your finger is when it touches the screen, it kind of spreads out a little bit. And so the issue with metal is it doesn't flatten out enough. We had purchased some Proto-pasta PLA. It's a conductive PLA to make stylus for touchscreens, and we found that wouldn't work by itself. And so I started looking for conductive foam. The conductive foam that came with various circuit components that we had purchased would work okay, but that was in limited supply, so I needed something that would work and was easier to get. And so with some experimentation of the stuff under my kitchen sink, I found that Scotch-Brite sponges are actually very conductive, and they work perfectly fine to manipulate touch screens. And so all we needed to do was make our stylus out of a conductive material, such as conductive PLA, and put a little piece of Scotch-Brite sponge in the end so that it would be functional. So that enables us to make a wide array of different types of custom designed stylus for people to use. This happens to be a typing cuff stylus. It just kind of fits on your finger. It can be custom bent and shaped depending on whichever finger the person wants to use to point, or whatever their longer finger is. So that's pretty effective. There's a variety of other stylus that we created. All of these are posted on the Thingiverse website. We have a ball stylus, different types of T stylus, this particular stylus. We started posting all of our stylus designs online for free on the Thingiverse website for anyone to download and use. I've had a few people comment and ask for directions, especially on how to make this one, and that's something I've been planning to do for a few years now. This week we've had some issues with our computer network. It's been up and down, so I decided to bring in all my video equipment and shoot some stuff this afternoon to demonstrate how we actually go about making one of these real quick. So hopefully you enjoy. Please like and subscribe, and comment if you have any questions. Thanks.
The first thing that you're going to need to do is to download the STL file for the typing cuff. In order to do that, you can find it posted on the Thingiverse website. We put it up in, I think, February 2016. So it's been there for quite a long time, and I think quite a few people have downloaded it. So just go to the Thingiverse website. That's Thingiverse, and you can search for typing cuff. I can see it already coming up. And there it is. Download it, and that will bring you to the page with some details about how to use it, and also the STL files and some images. So you can see some pictures of it, of the printed product that's been formed. This is what the actual file has in it, and after you print it out, you will need to go through and heat it up and bend it to shape. But to get the files, go to Thing Files and select Revision 5. That will download it for you. And so once that's done, we can minimize this window and go to your slicing software. We use Cura for Lulzbot because we've got a TAS 5 and the Rehab Engineering Workshop. And we'll open that file, Cuff Stylus. And so that will bring up the 3D printable file. we have loaded the printer with Proto-pasta, Conductive PLA, and that's what we use to make this conductive so that it will work with an iPad or with Android devices. At this point in time, when you first load it into your slicing software, you can use the tools built into it to change the scale. So if you needed to make this fit a smaller or a larger hand, you could scale it up or down. You can also rotate it on the build plate. I'm going to rotate it 180 degrees because for some reason we've been having a problem with things printing on the back right corner of our build plate. We've tried adjusting it and it's still kind of wonky, so I'm going to just turn it around so that it prints on a better part. The next thing you need to do is go through and set up your printer material so that you have the temperatures and everything. And so for this, I've actually created a Proto-pasta Conductive PLA profile, and if I go in here, it's a custom profile. And so the build temperature that we're using, I know that the Proto-pasta website recommends lower temperatures, but we've been having problems with it printing properly on our particular rig. So I've got it set to 230 degrees C for the print temperature, and let's see, I also increased the build plate temperature to 110 degrees C, so that seems to work pretty well for us. Of course, your mileage may vary on different printers, but that's what we've got for ours. Now at this point in time, you can save this to a file. Right now I don't have this laptop plugged in to the printer, but typically I would just plug it in and it will give me the option to print to USB, and that would set the printer going. So we'll do that. You can see it print, and then I will demonstrate how to quickly form and shape the stylus to your hand, and we'll also talk a little bit about a conductive foam to go into the end.
Now that the print is done, we've let the build plate cool to about 60 degrees Celsius, and we should be able to pry this off now without damaging it, hopefully. There we go. And so what we'll need to do is clean this up a little bit and then bend it to shape using a heat gun. Now that we've completed the print, I've taken the plastic off the print bed, and I'm just going to clean the edges real quick before we finish shaping it. Pretty clean. There's a little bit of plastic here to peel off, but basically it's pretty good. Alright. So in order to actually turn this into a typing cuff stylus, this is currently set up for right-handed use. We need to form this finger cuff, and then the rest of the cuff would go across the hand. This has been sized for my hand. So what we'll do is we'll use a heat gun here. It's got to heat up. With the heat gun up to temperature, we're going to start forming it based on where I want to bend it. So I'm going to apply heat to this section first to wrap it around my hand. Doesn't take much. Maybe a little bit further here. And we'll just hold it while it cools in shape. PLA has a fairly low melting point, so it doesn't take much heat. So we want to make sure it springs into place. That's pretty good. One of the things I like to do with my typing cuff is I like to have this bent a little bit for someone who's got difficulty. I want to bend this piece down so that they can slip their hand in more easily. So just heat this up just a smidgen. I just want the very end of that to bend down ever so slightly. Let it cool. It'll keep its shape. And then the same up here. Maybe just have a little bit of an uplift, curve up. Again, so someone who's got difficulty using their hand can just slide that in. So I'm going to heat this up just a little bit. Just a little bit more. So it'll maintain a nice shape, again, so your hand can slide in there more easily. The next step is going to be to heat this finger cuff up right here. Yes, I know. Some people have a longer index finger. It happens to be my middle finger's a little bit longer, so I'll use that for pointing. The shape of the cuff can be adjusted based on whichever finger is longer for somebody. It's a little on the hot side. Woo! Okay. So just bend it up a little bit. And again, let it cool. You can do this with a hairdryer also. The heat gun just makes it faster. Alright, so kind of get that into shape. So not too bad. So now we have it where it can slide on fairly easily. Hook up. The last step with this, because we want to be able to use it with an iPhone or iPad, is to bend the end of the stylus down. And again, we just heat it up a little bit. There we go. And just kind of bend it down based on what the needs of the end user are. And again, that'll cool off. I switched my heat gun to the no heat setting to cool off the element before I shut it off. It just kind of protects the gun, keeps it from damaging itself. So the last step in this process is to put a little bit of conductive foam in the end of the stylus. There's a lot of different types of conductive foam out there. When I first started doing this, I was experimenting with what I had access to, going through my pantry basically, and I found that Scotch-Brite sponge, unused, fresh, brand new Scotch-Brite sponge, is conductive. And so that's a fairly inexpensive source, very easy to get for conductive stylus foam. So what I do is cut a little chunk of the soft blue sponge off, and we'll try and square it up a little bit. And I just kind of twist it tight, and I can get it to feed down in here. and just leave a little bit sticking out the end there. And that is a 3D printed cuff style stylus. It's compatible with iPad and Android devices. So with this cuff stylus, it gives us the ability to now use an iPad. As far as I can tell, it works with all modern touchscreens without any difficulty. It works with my Android phone just fine. I just need a better mount. So we have full capacity to use the iPad. If I had it in a solid mount, I'd be able to press my home button and be able to navigate my iPad without much difficulty. So that's it. That's a typing cuff stylus for someone with limited use of their hands. I hope you enjoyed and learned something. Please like and subscribe.